Simarpreet. Very good afternoon. Yes, exams around the corner now, very near. So let us try and do as much as we can. Yes, Anushka, very good afternoon. We'll try to do as much as possible for correlation, and I will touch upon regression also, so that and we'll take the theory questions on correlation and regression. Uh, so I have a lecture, I think, day after, and then we could concentrate on the regression sums that time. Okay, so let us begin. So, what is correlation? Now, suppose you're a group of friends after your exams, obviously. You start going and having food at having fast foods. Okay. Now, just after the exam, your parents also won't object. So you go once in a while, have fun with your friends and come back, no problem. But then some of the students, just because they've now finished their 12th, now they're joining college, they start eating more of fast food. Now, what happens is there is a study that is going on about the weight of the students in the classroom versus the number of times they are visiting uh, fast food per week. Okay. Now, obviously, what is going to happen is that either the more you eat fast food, the more you gain weight, or the more you eat fast food, the less you like your weight decreases, which obviously won't happen, but or there will be no change. So, when we want to see this, okay, when we want to see whether there is any relation between fast food and weight of the person, and then we want to see how close that relation is it affecting a large amount, or is it having a small impact? So that is known as correlation. Okay. And the other way around, like once I have the weight of the person and I regress it using the regression line to see how many times a week that person is having fast food, that is known as regression. Okay. So that is a simple, easy to understand example. Now let us go into actually how we are working with correlation and regression. Correlation measures the strength. अभिनंदन, गुड आफ्टरनून। कैसे हैं? हम तो अच्छे हैं, आप बताइए आप कैसे हैं अभिनंदन? Correlation measures the strength and direction of the relationship between two variables. Okay. The correlation coefficient ranges from -1 to +1. This is, I mean, this why I have written it right in the start is that is one thing, if you keep in your head, you will not get confused whether it is a correlation, some regression, what not. Okay. R is going to lie between -1 and +1 only. Regression, on the other hand, is used to predict the value of one variable based on the value of another. The regression line, it is also called as line of best fit, is given by the formula y is equal to mx plus b. Okay, so it will be using this, you could find the value. Okay, so it is used what to predict. And what does correlation gives you? Strength and direction. Okay. Now, where do chartered accountants use correlation regression? In auditing, identify unusual transactions by correlating values, various financial metrics. Then financial analysis, predicting future analysis, future financial performance based on historical data. And risk management, assessing relationship between risk factors and the outcomes. Okay. So as you know, all these things you will be doing in your CA curriculum and later on in your practice. So you can understand the importance of this chapter. Now, before we go into actual correlation regression, there are two concepts, that is univariate data and bivariate data. univariate and bivariate data. So distribution. Univariate distribution is the simplest distribution. Okay. It takes data and summarizes it. Then it tries to find a pattern. For example, I have a manufacturing business. So I have invested, say, 50,000 rupees in that business, and then I'm earning a profit of 1,000 rupees. Now, what I want to find out is if I increase my investment to 70,000, how much is my profit going to be? Okay. So I will work it out and I will find it. Okay. So for every different scenarios, I will work it out. So that is known as univariate distribution. And we use mean, median, mode, quartile, dispersion, range, standard deviation, etc. on all this data. And then we come to certain conclusion. It can be easily represented as frequency chart, bar chart, histogram, pie chart, etc. Okay, so that is univariate data. Bivariate data is when data is collected about two variables. Let's see what's the question. Yes, Harish, good afternoon. Okay. Yes. So this is univariate and bivariate. Now coming to marginal distribution. Okay. So suppose I have 1, 2, 3, 4, 4, and 3. So 3 by 4 matrix. Okay. So x1, y1, x1, x1, y1, x1, y2, x1, y3, like this, And I put in the probabilities. And then what happens is this 4 plus 2 plus 1 plus 1, this 8 by 32, all this, like total of the columns, total of the rows, these are the probabilities that are found in the margins, and these are known as the totals of the probabilities for the particular row or for the particular column. So joint and marginal distributions of a pair of discrete random variables x and y, the values of the joint distribution are in the 3 by 4 rectangle. Okay, so this has all the information. This is the actual information and this is the additions. Okay, and this is known as the marginal distribution. Okay, then conditional distribution, it is the probability. Now as the word tells you, what is conditional? Condition means you have one condition and then you want to see how the whole distribution is going to behave. Now, for example, this is the rolling of two dice. Okay, this is rolling of two dice. Okay. Now, what happens if I say that on one face, I have the number 2. Okay, in one face, I have the number 2. What are the possibilities on the other dice? What are the possibility on the face of the other die? You can have a 1, you can have a 2. So it can be 1, 2, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, right? So this is the one marked in blue is known as the conditional probability. Now, in this case, what is happening? Both are possible. Why? Because you cannot distinguish between one die and the other dice, right? So that is why here you will have this, the plus shape. So the conditional probability is the probability distribution for a subpopulation. So here what we are doing is, we are taking the population and then we want to concentrate on 2 on the face of the die. Okay. It shows the probability that a randomly selected item in a subpopulation has a characteristic you are interested in. So what was the characteristic I was interested in just now? Was the face should contain the number 2. Yes, Garv, good afternoon. Okay. So see, here we have talked about what is bivariate frequency, marginal, conditional. Okay. Now, let us talk about correlation, types of correlation, positive and negative. And how do I measure correlations? There are 4 methods: scattergram, Pearson, Spearman's rank correlation, and coefficient of concurrent deviation. Okay, and then we will go to regression next time. Yes, Tanishka, good afternoon. So let us consider the example again of the investment. So we want to see whether when I increase my investment, does my profit increase? The extent of relation between them. So suppose I double my investment. If I double my, does my profit double? Okay, all these questions I can answer using this correlation. Okay, so co and relation means cause and effect relationship is here. So increase of investment, is it giving the effect of increase in profit? And these are the 4 methods: scatter diagram, product moment correlation, that's Carl Pearson; rank correlation, that is Spearman; coefficient of concurrent deviation. Why I'm writing this so many times is because these names sometimes, they come in separately. Like here, they may ask you only, they may say, find the product moment. And you're so used to talking of Carl Pearson. It should not happen. Okay, so you should know that this and this are the same. Okay, and Spearman means rank. Correlation analysis is a statistical method used to evaluate the strength of the relationship between two quantitative variables. What is the correlation coefficient? This is also these 2, 3 slides I'm repeating so that it will stay into your head. It is represented by the symbol R. It ranges between -1 and +1. So the moment you do a calculation and you are getting R more than 1 or less than -1, that means there is something arithmetical mistake. So please check again. It quantifies the direction and the strength of the linear association between the two variables. So now if I say R is equal to 0.9, then it is a strong positive association. There is a plus sign here and there is a number which is very near 1, then it is a strong positive. R is equal to -0.2 suggests a weak negative association. R is equal to 0, no linear association between two continuous variables. So let us see the properties. Again, R is unit free. Okay, these are some questions that they can easily ask you about the properties. On all chapters in mathematics and statistics, you should make it a point that you have done all your properties of all in all the chapters. Wherever you see properties, just go through them. R is unit free. The coefficient of correlation always lies between -1 and +1. Okay, this is very important, including both the limiting values. Okay, see, you can get a question. Coefficient of correlation lies between -1 and +1. That is correct. But then they will say excluding limits, including limits. So that's it why you should always know including both the limiting values. Okay. Change of origin and scale. If A, C are origins of X and Y and B and D are scales such that, okay, so if U is equal to X minus A upon B and B is equal to Y minus C upon D, then RUV is equal to RXY BD upon mod B into mod D. What does this mean? BD upon mod B mod D. Mod B means you're taking only the positive values. Okay. So what happens here? In the denominator, you're getting positive. What happens? B and D. B and D may be positive or negative. Okay. So what this means is, and BD upon BD means they are going to cancel out. What is going to remain is the sign. Okay. So you RUV and RXY will have same magnitude, okay, equal magnitude, but may have different signs, okay. क्योंकि BD अपॉन BD हम करते हैं तो वो कैंसिल हो जाता है, तो उसके बाद क्या होता है, क्या बचता है, उसमें सिर्फ साइन बचती है. तो magnitude is going to remain the same, but sign may be different. So we are going to do the sums, but just once we doing the sums, because we don't have the time to draw the graphs, etc. So I've just drawn it for you for your reference. So suppose this is my x and this is my frequency for that x, and I plot them. So the blue ones are the plotted ones. Okay. Then I find an R and then I draw the line. This is the line. Okay. So as you can see, it is going from top left to bottom right. Top left to bottom right is a negative. Okay, is a negative correlation. Okay, and once you do the calculation, you will see it is minus 0.93245. Okay, so it is negative. So sometimes they may even show you a graph and ask you whether it is a positive, negative correlation or non-correlation. Okay. Now let us see another example. Here also x is given, frequency is given, and then we plot it. It is from bottom left to top right. So it is going from bottom left to top right. This is a positive correlation. Okay. So this is, you can see, if you calculate, you will see 0.95. And here you can again see this. Okay. So just a way for you to imagine and remember things, okay? Measures of correlation. As we are talking, there are 4 measures of correlation. To measure correlation, scatter diagram, Carl Pearson, product momentum, correlation coefficient. इतना बड़ा नाम है, आपको डरने की बात नहीं है, बस आपको याद रखना है, या कहीं पे कोरिलेशन कोएफिशिएंट आ गया ना, तो हमें वो ढूंढना है. Then Spearman's rank correlation coefficient and coefficient of concurrent deviations. Okay. See what happens. Calculations are mostly on this formula. Bigger calculation. This is for rank. Rank is for qualitative. For qualitative or attributes, you are using Spearman's rank. Okay. Beauty pageant. Okay. Singing competition. So that type. Coefficient of concurrent deviation, that is, I just want to have a fair idea, I just want to see whether there is a correlation or not, and what want to get an idea about what type of correlation there will be. Then I will go in for concurrent deviations. It's very simple. I just subtract and, very simple calculation I find out. Okay. Then after that, I can draw a scatter diagram and see whether what I have obtained from concurrent deviation is tallying with that. And then I would like to go in for actual concrete calculation. Then I will go for Carl Pearson product moment correlation coefficient. Okay. See. A scatter diagram, also known as scatter plot, is a graphical representation of the relationship between two variables. It is a powerful tool for visualization of the correlation. Visualization मतलब देख के पिक्चर देखते हैं ना, तो फिर हमें ज्यादा अच्छे से पता लगता है. So that is why you are able to see and understand the correlation between variables and can provide insights into strength, direction and form of the relation. So strength, direction and form. Okay. So here, if you see, the dots are quite nearby and it is going from bottom left to top right. So it is positive. This, all the dots are on the same line. This is perfectly positive correlation. Okay. Then top, left to bottom, right, it is going downwards, so it is negative. And this, all the dots are lying on a straight line, perfectly negative correlation. This, when there is no particular method, there is no correlation. No correlation. And something like this is curvilinear. Okay. Now let us go to the Pearson. This is the most widely used measure of correlation and is suitable for data that is normally distributed and has a linear relationship. It measures the strength and direction of the linear relationship between two continuous. So it has a linear relationship. Data which has um, linear relationship, for that you can use Pearson correlation coefficient. Okay. Spearman's rank correlation coefficient, it is a non-parametric measure of correlation, means there is no one parameter that is going to define it. Because what here we do is we just find the difference between the ranks given between two people. Like in mode, we said you can have multimodal, and so similar to that, there is nothing over here. Okay, so it is called as non-parametric measure of correlation. It measures the strength and the direction of the monotonic relationship between two variables. Now, coefficient of concurrent deviation, it is a measure of correlation that is closely related to the Pearson correlation. Okay. The coefficient of concurrent deviation is sometimes used as an immediate step for calculating the Pearson. Okay, so when I want to find out, I'll just first find out concurrent deviation, but I get a fair idea and then I go to the actual Pearson. The scatter diagram provides a visual representation. Coefficient of concurrent deviation offers a numerical measure. Okay. So scatter diagram is giving you a visual impact, and concurrent deviation is giving you a numerical value for it. Now these are the formula. Now see, there are many ways to do the sums. The sums are like the whole explanation is already given in the book, but the sums that are going to come will be very crisp, precise. You will not be required to draw huge tables. Those are there for your understanding, for you to be able to know what how the flow of events occur, how you come to the value of R. Okay. Now this formula is the most go-to formula. Okay. This formula, once you know, what happens is you can always add, subtract from it to get the other formula. This will not this will ensure that you don't make any mistake. Okay. Now what is R? R is n into summation xy minus summation x into summation y. What is the difference between this and this? Summation xy means first you multiply x with y and then you add it. This means you are multiplying x with y and then adding it. Here what is happening is you take the summation of x and you multiply it with the summation of y. ओके यहाँ पे मल्टीप्लीकेशन होने के बाद ऐड हुआ है, यहाँ दो अलग मल्टीप्लीकेशन है, ये पहले एडिशन हो गई है उसके बाद मल्टीप्लाई हो रहा है अपॉन n summation x square minus summation x the whole square n summation y square minus summation y the whole square. वापस ध्यान दीजिए, x square means every x has to be first squared and then added. Every x has to be first squared and then added. And here you just have to add the x and then you square it. So this is one formula you must know. Now this is, as you can see, that it is representing what? It is representing covariance. There is a formula for standard deviation, variance. So all those things we are going to write down. Okay. The other formula which is very commonly asked is this. Rxy is equal to covariance xy upon sigma x into sigma y. So you could use this, or you have symbol wise, you have covariance xy sigma x into sigma y. Okay, standard deviation of x into standard deviation of y. Okay. Now, revising with the covariance formula, covariance xy summation x minus x bar into y minus y bar summation upon n. Okay, so x minus x bar into y minus y bar upon n. So this is equal to, this can also be written as summation xy upon n minus x bar y bar. Okay, and sigma x is equal to summation x minus x bar whole square. This is equal to summation x square upon n minus x bar square and sigma y. Okay, so you have covariance xy. You can also have that as summation xy, that is you first multiply and then add upon n minus x bar y bar. What is x bar y bar? Mean. Okay. And sigma x is equal to square root of summation x square upon n minus x bar square. Okay. So let us try to simply put this and get this answer. So can anybody now, like we will first put in values. R is equal to n summation xy. What is the value of n? N is 6. 6 summation xy 20485 minus summation x into summation y. Summation x is this much, summation y is this much. 245. Oh, sorry, 247. 247 into 486. Okay, divided by. So first we'll solve the denominator. 6 into x squared. 6 into 11409 minus summation x is 247 whole square. And this is 6 into summation y square is 40022 minus summation y 486 whole square. Okay. Now can anybody tell me the denominator first square root and the second square root? Two 47. Two 47 square. Square of 247 is 61009. Yes, thank you, Anushka. And 6 into 11, 409 is 68454. Yes. Thank you. Yes. Can you subtract and find the square root, Anushka? Thank you so much. Yes. Excellent. So I think now everybody's got an idea. So you have to solve this, then you have to solve this, you have to multiply, and you will get the answer as 0.5298. Okay. Now let us go to the other sum. Now if you have this kind of x and y, and then you are asked to find the value of r, what you must do is write down your x. Okay, x, then y. Okay, in the last you will get summation x, then you will get summation y, then you can have x into y, so you will get summation xy, then you will have x square, you will have summation x square, then y square, and you will have summation y square. Okay, so 2, 3, 5, 5, 6, 8, and this is 9, 8, 8, 6, 5, 3. Okay. Can I get the values here? So this is 18, this is 24, this is 40, this is 30, this is 30, this is 24, 4, 9, 25, 25, 36, and 64. And here you will have 81, 64, 64, 36, 25, and 9. Okay. So you will find these values and then you're going to substitute and you will get the answer. Okay. So it is done in your this thing also. It is a solved example in your textbook. So in your study material, so you will be able to find these values. Okay. Can you see now these values are so simple to calculate? And once you do that, all you need to do, remember, is this formula. Okay. Now let us go to the other types of sums that you may be asked. If two variables x and y if for two variables, x and y, covariance, variance of x, variance of y are this much, find the correlation coefficient. Okay. What is the formula for R? R is covariance xy upon sigma x, sigma y. What is given? Covariance of xy. Okay. Covariance of xy is given to you as 40. Variance of x is given to you as 16. And variance of y is given to you as 256. Now, here what is required is standard deviation and not variance. So, if variance of x is this implies sigma x is equal to square root of 16, which is equal to 4. Variance of y implies sigma y is equal to square root of 256, which is equal to 16. Okay. Can you see now? So, I have the value of covariance as 40. Sigma x is 4 and sigma y is 60. So, how much is this? 4 tens are, 5s are, 8s are, 0.625. Okay. Have you understood till here? Please put in the chat box whether or not you've understood. Okay, don't take stress about the exam. Now you're doing so well. Okay, you should be able to feel very proud about yourself. Yes, do put in the chat box. Yes, Tanishka understood. Yes, thank you, Anushka. Yes, Natasha. Yes, Mehak, Kavya, Jyoti. Excellent. Wonderful. Wonderful. Okay. Can you see now? You don't have to worry about the chapter. This is a scoring topic. And once you are able to understand all, it may look like many formula. It's not like that. You just need to know two formula and then you're good to go. Now let us go to the Spearman's rank correlation coefficient. Okay. What happens is that I want to, especially you see, when there is a dance competition, so what will happen is many groups will come and dance. So how do you judge if it is a classical dance competition, like a Bharatnatyam or a Kathak? Then there are set rules. You should be able to do all the different parans and tal and everything. Then it's easier to judge. But when you are having a simple competition, dance competition, then what you do is you appoint judges. And then you don't want any bias, so you appoint more than one or two judges. And then what you do is you take the ranks of all, given by all of them to all the dance competitors, and then you come to a winner. So in that case, how do I translate a qualitative this thing? Because I can't measure how good somebody dances. Okay. So what we do is, in this case, for the qualitative characteristics, we use what is known as Spearman's rank correlation coefficient. In this, we are concentrating on how close two judges have given the marks. Okay. It finds level of agreement. Okay. How close. Simpler, used to get first-hand impression. R lies between -1 and +1. Just because it's a rank correlation does not change the properties. Properties are going to remain the same, -1 to +1. Okay. So di is equal to xi minus yi represents the difference in ranks for the ith individual. Okay, this is there uh, for you to understand the formula, but we will be doing simply using this and this. Now, the simplest form is R is equal to 1 minus 6 summation d square. We'll come to what is d square upon n into n square minus 1. Please remember, ये जो है ना, ये लाइन इस 6 समेशन डी स्क्वायर के नीचे है, हाँ, ये एन स्क्वायर माइनस 1 ये 1 के नीचे नहीं है. Now, what happens is that when there is a tie, then you use this factor. This factor. This is T3 minus T upon 12. And there is a summation. Okay. बहुत बच्चे इसमें कंफ्यूज होते हैं, लेकिन कंफ्यूज होने वाली बात नहीं, अभी हम बताएंगे तो देखेंगे आप. How many times the rank is repeated? Okay, so that way you will see. Okay, you will have to add this. Sometimes it is repeated twice. Repeat means at least one more time. So twice or thrice. Okay, so that way you have to see. Now let's see. The numeric ranking will be from 1 to n. Okay, so I have suppose 10 contestants. So I will give the rank from 1 to 10, obviously. If a number is repeated twice, then this T3 minus T upon 12. Okay. So if a number is repeated twice, then 2 will be what? T will be 2. So 2 cube minus 2. How much is 2 cube? 8. 8 minus 2, it will be 6. What happens if the number is repeated thrice and 3 times? So then it will be 3 cube minus 3. 3 cube is 27 minus 3 is 24. Okay. So I'm just calculating the numerator. Okay. So this thing written in red, if you remember, you will never go wrong. Okay. उससे ज्यादा पुश आएगा ही नहीं कि 4 बार रिपीट हुआ है. 10 में से 4 बार रिपीट हो गया तो उसमें कोई लॉजिक ही नहीं बचेगा. ठीक है. So you have to just remember this much. If you could do that, okay. So you know this 6 upon 12, how much will it be? 0.5. 24 upon 12, how much will it be? Sorry, 2. Okay, this is 2. Is it clear? Now let us try to do this sum, and once we do that, you will understand. Okay, I forgot to draw the table. No problem. Okay, so 80, 56, 50, 48, 50, 62, 60. Okay, this is marks in eco. Now what I will do is, okay, I will first see which is the highest marks. Okay, and before that I'll see count how many numbers are there, how many pairs are there. 1, 2, 3, 4, 5, 6, 7. So my rank can go from 1 to 7. Okay, so what is the highest number here? Highest number is 1. I will give it a rank 1. Okay. The next number is 62. I will give it 2. Then third rank is 63. Then fourth is 56, 4. Now I can see this is repeated, and here So I have this. Now what are the next rank? 1, 2, 3, 4. Next rank are 5 and 6. Next ranks are 5 and 6. So I will write 5 plus 6 divided by 2, which is equal to 5.5. जो next ranks है उसको देना है 5.5 and 5.5. Now 5 has been exhausted, 6 has been exhausted. Next rank will be 7. Okay. Once I have done that, I will write the other one. Then I'm going to write marks in statistics. 90, 75, 75, 65, 65, 50, and 65. Okay. So I can already see 75. 75 is one pair and 65 is repeated three times. 1, 2, and 3. Okay. So that helps me actually to know. So 90 is first rank, no problem. Now second rank, I have again second and third. Okay, so 2 plus 3 upon 2, that is 2.5. So this is 2.5. This is 2. Okay, I should write it in the other color. Okay, this is 2.5. This is 2.5. Okay, that is 2 and 3. Now 1, 2, and 3. So 3 has gone. 4 plus 5 plus 6 divided by 3. Because 65 is repeated 3 times. So 4 plus 5 is 9. 9 plus 6 is 15 upon 3 is 5. So this will have a ranking 5, 5, and 5. Now 4, 5, 6 has already gone. Remaining is 7. So this 50 is going to get a rank 7. Now I will now find the difference. 1 minus 1, 0. 4 minus 2.5, 1.5. This is 3. This is 2. This is 0.5. This is minus 5. And this is minus 2. Now what you have to do? You have to difference square. Difference square. 0 square, 1.5 is 2.25. This is 9. This is 4. This is 0.25. This is 25. And this is 4. Can anybody tell me the total? How much is this? Summation d square. Yes, Kavya is saying 44.5. 44.5. Yes. Thank you. Now let us see. 50 repeated twice, right? So this is going to be 2 cube minus 2 upon 12, which is equal to 6 upon 12, which is equal to 0.5. Then 75 is repeated twice, 2 cube minus 2 upon 12, which is equal to 6 upon 12, which is equal to 0.5. 65 repeated thrice. So this is going to be 3 cube minus 3 upon 12, which is equal to 24 upon 12, which is equal to 2. How much is this plus this? This is 3. Okay. So once you have this, Yes, thank you, Tanishka. So now let us put in the final value. R is equal to 1 minus 6 summation d square plus summation t cube minus t upon 12 upon n into n square minus 1. So how much is this? 1 minus 6 44.5 plus 3 upon n is how much? 7. 7 into 48. Yes, Deepa, good afternoon. So can I get the final answer? 47, 49. Yes, very good, Tanishka. This is equal to 0.15. Okay. Yes, everybody's got now. Have you all understood this? Hmm? They in the book they will show it simultaneously. So what happens is that in the paper also you don't have so much of space. So what you do is just do it there itself. जहाँ 50 लिखा रिपीट हुआ वहां पे तुरंत उसको कैलकुलेट कर लीजिए, जहां पे 65 रिपीट हुआ वहीं पे कैलकुलेट कर लीजिए, उनको सबको बस ऐड करना है आपको. ओके. यस. Excellent work. Now let us take a simpler example. One, two, three, four, five, two, three, 1, 5, 4. As you can directly see, there is nothing common. Okay. So just find the difference and then find the difference square. So difference is -1. -1 square is 1. -1, 1. 2, 4. -1, 1. 1, 1. How much is this? 1, 2, 3, 4. This is 8. Summation d square is 8. So R will be equal to 1 minus 6 into 8 upon 5 into 24. 8 3s are 3 2s are 1 minus 0.4, which is equal to 0.6. Yes? Yes, Ishika. Excellent work. Everybody was able to calculate. So you can get such simpler sums also. Okay. Now this is also a very good example I've just directly taken. For a number of towns, the coefficient of correlation between people below the poverty line and increase in the population is 0.5. Okay. If the sum of squares of the difference in ranks awarded to this factors is 82.5, what does this give you? This is giving you summation d square. Okay. sum of the squares of the difference in ranks. Okay. Sometimes, we just remember d square. We don't know what it is about. We don't remember its name. But this is an example where you just by knowing that name, you can get full marks. Deepa, you can't use log on a normal KCO. You can't do that. You need log tables. And for that, mostly any question that requires you, they will give you the log value or simple, like log 2 is 0.3010. No? That you must know. Only those will be needed. Summation d square. Okay. So once I know this, what will happen? What are they asking? Find the number of towns. They have given you R, they have given you D, and they're asking you to find N. Okay. So 0.5 is equal to 1 minus 6 into 82.5 upon N into N square minus 1. Okay. So you can like take this to this side and 0.5 to this side, and you solve this, you get N is equal to 10. Okay. As N must be an integer. So 10 towns, then they do the calculation and they get um, you have taken the data of 10 towns and drawn this conclusion. Okay. Find the coefficient of correlation R between X and Y when covariance XY is equal to minus 16.5, variance of X is 2.89, variance of Y is 100. So covariance is given to you minus 16.5, variance of X is equal to 2.89, implies standard deviation of X is equal to square root of 2.89. How much is that? Variance of Y is equal to 100, implies standard deviation of Y is equal to square root of 100, which is equal to 10. How much is 2.89? Excellent, Jyoti, 1.7. So R will be equal to how much? Minus 16.5 upon 1.70 into 10. So can you find the value? Sixteen point five divided by 1.7. What is the answer? 0.97 with a minus sign. Yes. Jyoti, why minus 1.65? This is divided by 1.70. And again, same thing. You cannot have the value of R greater than or less than, greater than 1 or less than minus 1. Okay. दो मिनट ब्रेक ले ले. Yes, thank you. Yes. Now the covariance between two variables x and y is 8.4. Their variances are 825 and 36. Calculate Carl Pearson coefficient of correlation between them. So R will be equal to 8.4 upon square root of 25 into square root of 36. So equal to 8.4 upon square root of 25 is 5 into 6. So this is equal to how much? 8.4 upon 30. Two, 8 and 0.28. Okay. Yes. Yes, Jyoti, very fast you've done. Now here what is given? R is given. Covariance is given. Variance of X is given and they're asking you to find the standard deviation of Y. Okay. Just be careful. This means standard deviation of X is square root of 9 which is equal to 3. So R will be equal to 7.6 upon, not R, R is already given, 0.28. 0.28, 7.6 upon 9 into sigma into, who is doing this? देखेंगे क्या कौन कर रहा है? हेलो, ये कौन कर रहा है? जानबूझ के कोई पढ़ा नहीं दे रहा है. वहाँ हो नहीं रहा है मेरा. हाँ, वहीं पे जाना चाह रही है. ये इसकी वजह से मेरा पॉइंटर उनके कंट्रोल में आ गया है, जो कोई कर रहा है. देखिए मैं यहाँ से वहां जा ही नहीं पा रही हूँ. वहां एनेबल एनोटेशन फॉर अदर्स ही आ रहा है. हाँ. नहीं, ये मैसेज आ रहा है ना, ही इज कंट्रोलिंग योर स्क्रीन. पता नहीं, मैंने गलती से किसी को हाँ कर दी शायद. ये तो कोई. था कौन है बंदा? ये एच नाम से जो है ना, उन्होंने किया है। एच कौन है? हाँ हाँ, हटा दीजिए थोड़ी देर के लिए, क्योंकि ये क्या बात हुई ना, उन्होंने नाम भी ऐसा रखा है, मुझे लगा आपने परमिशन दी है। हम्म। और एक बार गलती से हो जाए तो समझता है ना, तो सॉरी फॉर ऑल दिस। लेट अस डू इट ओवर हियर। ओके। हाँ, वो कर देती हूँ मैं पहले। नहीं, यहाँ पे देखिए वही आता है, एनेबल आ जाता है, डिसेबल आ ही नहीं रहा है। को होस्ट नहीं हो क्या? है ना? पता नहीं, वहां आ नहीं रहा आज। रोज तो आ जाता है, थ्री डॉट्स के वहां। देखते हैं। ओके, सो व्हाट वी हैव इज 0.28 is equal to 7.6 upon 9 into sigma y. So sigma y will be equal to 7.6 upon 0.28 into 9. So 7.6 upon 0.28 into 9 is how much? 2.52. So 7.6 divided by 2.52, 3.01 होना। No, this is 3. कौन है ये चेतन महान सर ये? कहाँ से आ रहे हैं ये लोग? दिस इज 3। दिस इज 3। So it is, okay, I have to redo the sum. Yes, 3.01. No, no. This was, variance of x was 9. So we have sigma x is 3. ये कुछ ये हो गया है, हैक हो रहा है कुछ। अब कुंज बिहारी आ रहा है। This is 0.28 is equal to 7.6 upon 3 into sigma y. So sigma y is equal to 7.6 upon 3 into 0.28, which is equal to how much? 3 into 0.28, 3 into 0.28, 0.84 into 7.6. So that is 9, 9.04, 9.04. यस ज्योति, करेक्ट। आप लोग को भी ये स्क्रीन पे दिख रहा है क्या, कुंज बिहारी जी? ये तो लिखने ही नहीं दे रहा मुझे कुछ। ओके। Okay. Now let us go to the next topic, that is coefficient of concurrent deviation. नहीं अभिनंदन, वो दूसरा व्यक्ति जानबूझ के वो खराब किया जा रहा है, मेरे हाथ में ही नहीं रहता फिर वो मैं इसलिए रब नहीं कर पा रही है, वो लिखने भी नहीं दे रहा है। देखो ये कुंज बिहारी हर 1 सेकंड बाद आ जाता है, सारे नाम अलग अलग नाम से वो कंट्रोल करना चाह रहा है ताकि आप लोग पढ़े ना। देखो अभी स्क्रीन आपको दिख ही नहीं रहा है, उसका ही वो आता रह रहा है। देखो उसको हिलाने की कोशिश करती हूँ तो भी वो इधर आ जाता है। ओके, this as I told you is a very convenient and easy way to find out whether there is a correlation between two variables. So what you have to do is, if other number in the succeeding number is bigger than the earlier number, you will add a plus sign. If it is less, you will write a minus sign. Okay. For both the variables, you will do that. After that, what you are going to do is you are going to multiply this plus or minus whatever it is, and then you are going to see how many plus signs you have. Okay. तो जब करेंगे तो आपके ध्यान में आएगा। सी क्या कर सकते हैं इसको। इफ साइंस ऑफ बोथ एक्स एंड वाई। okay. मैं रिज्वाइन करती हूँ। देखते हैं। हेलो। नहीं, ये वापस वही आ रहा है, अभी महेश अग्रवाल को ही है। Okay. So what you have to do? Now let us see. This is the sum. So what is given to us? Year is given 1990 to 97. Price is given and demand is given. Now you know the relation. You've all studied economics. What is the relation between demand and price? Okay, so we are trying to see whether there is a positive relation, negative relation, or no correlation. Okay, so let us see the first question. Now, what I'm going to do, I'm going to write 90 to 97 here, and I'm going to write the price here. Then what I'm going to do is, I'm going to see how many numbers are there, pairs are there? 1, 2, 3, 4, 5, 6, 7, 8. So n is equal to 8. So m is equal to n minus 1, which is equal to 7. ये वाला स्टेप पहले करके रखो, वरना गलती से 8 ले लेंगे तो फिर सब आंसर गलत हो जाएगा. ओके, सो नाउ वी हैव टू सी 28 to 25. From 25 to 28, is it a positive? Yes. 28 to 30, positive. 30 to 23, negative. 23 to 35, positive. 38, 38 to 39, 35 to 38, we've done positive. कहीं से और से हो रहा है ये. जूम को आपको कंप्लेन करनी पड़ेगी. अपना तो इतना बड़ा क्लाइंट है हम जूम के. 25 to 28, there is a positive. ये लिखने ही नहीं देता मुझे. Positive. 28 to 30, positive. 30 to 23, negative. 23 to 35, positive. 35 to 38, positive. 38 to 39, positive. 39 to 42, positive. So what has happened to the price? Price has increased. Now let us see for the demand. 35 to 34, negative. 34 to 35, क्या करें इसका? Yeah, just see whether I can take the page down. Yes. 34 to 35, there is a plus sign. 35 to 30, negative. 30 to 29, negative. 29 to 28, negative. 28 to 26, negative. 26 to 23, negative. Okay. Now, once I have done this, now what is going to happen? I'm going to multiply plus into minus. Okay. This plus into this minus, what am I going to get? I'm going to get negative. Plus into plus, positive. Negative into negative, positive. So this is the most important. जो जल्दबाजी में हो जाता है हमसे, तो ये याद रखना है. This is also negative. This is also negative. Negative into negative is giving me positive. Then plus into minus, minus, then minus, and then minus. So how many plus do I have? I have two pluses. So that is called as C. C is 2. Okay. M is 7. C is 2. Okay. So I have got C as 2. M as 8 minus 1, 7. I have to just substitute over here. So what we have done here is, so C is 2. So I have 2 into 2, 4. 4 minus 7. Now 4 minus 7 is minus 3. Now I cannot find the square root of minus 3 and therefore this plus or minus sign is there. इस अंदर के प्लस और माइनस साइन का वही इंपॉर्टेंस है कि अगर आपका जो अंदर का नंबर है वो नेगेटिव आ रहा है तो उसको आपको माइनस से मल्टीप्लाई करना है। अगर प्लस आ रहा है तो प्लस से मल्टीप्लाई कीजिए, मतलब कोई कुछ करने की जरूरत नहीं है, because I cannot take the square root of a negative number. Okay, so you have this. So 4 minus 7 is minus 3. Minus 3 into minus, you will get plus 3. So what is your answer going to be? Square root of 3 by 7, which is equal to 0.65. Okay. So this is how you will be answering. I hope you're understanding amidst all this chaos. Thank you all for your patient hearing. Now, then you have this another very wonderful sum. 10 pairs of observations, number of concurrent deviations was found to be 4. See, for 10 pairs of observations, so n is equal to 10. So m is equal to 10 minus 1, which is equal to 9. Number of concurrent deviations, so c was found to be 4. So what is the value of the coefficient of concurrent deviation? So r is equal to what? Plus or minus square root of plus or minus 2c minus m upon m. So how much is this going to be? Plus or minus square root of plus or minus, that is going to be 8 minus m is 9 upon m is 9. 8 minus 1 is minus 1. Minus 1 into minus 1 will become plus 1. So this is going to be, because there is a minus sign inside. ओके जब आपका अंदर माइनस है तो इन दोनों बाहर के दोनों में से जो अंदर की साइन आएगी वो चूज करनी है। अभी हमारे अंदर की साइन माइनस आई है तो बाहर भी हम माइनस लेंगे। ओके सो दिस इज माइनस अंडर रूट ऑफ 1 upon 9. Square root of 9 you know is 3. So answer will be equal to minus 1 by 3. Isn't it? It's a wonderful chapter. Yes, I used to love, even from college days, I used to love correlation regression. So next is about the property. The coefficient of correlation between x and y is 0.6. The two variables are given by this. Okay. See, now what is happening is u is equal to x minus 3 upon 2. So that is b is how much? 2. This is u. And v is equal to y minus 2 upon 3. So write it over here. b is equal to 2, d is equal to 3. दोनों का साइन एक है, पॉजिटिव है दोनों, तो दिस इज गोइंग टू बी व्हाट? दिस इज गोइंग टू बी इक्वल टू 1 plus 1. So what will be the coefficient of RUV? How much it will be? It will be same 0.6. Okay. Now an important this thing. Yes. Now determination and non-determination. See, what happens is that, like, you've seen that if you eat a lot of fast food, your weight is going to increase, right? But sometimes the weight gain has other reasons also. So when I'm finding the correlation between the weight and my fast food, then what is called is coefficient of determination. Means what? How much of the change can be explained by that very factor and then some part of it will not be able, we will not be able to explain. That is innately because we are not considering all, we are just considering bivariate, isn't it? Because we are considering bivariate data. For something to happen, there will be other factors also, right? So for that, we have to we call what is known as R square, which is called as explained variation. And then we are saying coefficient of non-determination, that is 1 minus R square. Okay, so R square is explained variation upon total variance, and coefficient of non-determination is 1 minus R square. Now, if R is equal to 0.6, if R is equal to 0.6, then determination is how much R square? That is 0.6 whole square. That is 0.36. That is, of all the changes, 36% can be explained. Then coefficient of non-determination is 1 minus R square, which is equal to 1 minus 0.36, which is equal to 0.64. Okay. These are very easy marks that you should not lose. If the coefficient of correlation between x and y is minus 0.9, then what will be the coefficient of determination? Coefficient of determination is R square, which is equal to 0.90 minus 0.90 whole square. Because it's a square sign, minus will get squared. So you will get the answer as 0.81. Okay. 0.81. So be careful, because in the answer they will obviously give you something with a negative also. Okay, but this is a square, so you will always get a positive answer. See, I'm just using the where I've already written the answers, okay, instead of actually solving them, because you won't be able to see also. So let me quickly take you through the theory questions also. Okay, bivariate data are the data collected for two variables irrespective of time. No. Suppose I want to compare prices. I cannot have price like if I'm comparing between two commodities, then what happens is, and I want to see impact of inflation, so I will compare the prices just now. Okay. If I'm comparing price rise of potatoes for many years, then it is a different thing. But then it is one univariate. Here we are talking of bivariate. So you are talking of two variables. More than two variables? No, because there are two. Two variables at the same point of time? Yes, that will be the answer. Two variables at different point of time? No. Bivariate is talking about two variables at the same point of time. So I'm trying to tell you how to read also, okay? For a bivariate frequency table having P plus Q classification, the total number of cells are just, for example, I have two rows and three columns. So x1, x2, y1, y2, y3. So how many will the cells be? 2 into 3, 6. So answer will be PQ. Then sum of the cells frequency in a bivariate frequency table can be negative, 0. It can never be negative. So it will only be equal to 0. Okay. For a P and Q bivariate frequency table, the maximum number of marginal distributions is 2. Okay. Because you have one like this, forget it. For a PQ classification, the maximum number of conditional distributions can be any number. Okay, P and Q. It will depend on how many, what is the conditions you are putting. Correlation analysis aims at predicting one variable for a given value of other variable. That is the regression. Establishing relationship between the two variables. Measuring the extent of the relationship, both B and C. So it not only established relationship, but also tries to measure the extent of the relationship between two variables. Okay. Regression is concerned with measuring the extent of the association between two variables. That is your correlation. Establishing a mathematical relationship between two variables. Predicting the value of the dependent variable for a given value of independent variable. I think A and C. Yes, both A and C. What is spurious correlation? It is a correlation between two variables having no causal relationship. Like for example, in the summers, all of us eat lot of ice cream. Okay. In the summers, because there are holidays, people go to beaches, okay, for the vacations. There are a lot of drowning incidents also because people are not used to swimming in the sea and still they go venture into the sea long distance. So does that mean there is because there is an increase in consumption of ice cream, there is an increase in drowning? Absolutely nothing, no? But it looks like that. So that is called as a spurious correlation, where there is no relation as such, but it appears so. So because there is no causal relation. Scatter diagram is considered for measuring both A and B. So linear also and curvilinear also. If the plotted points in a scatter diagram lie from upper left to the lower right, okay, वो मैं बार बार बता रही हूँ, आपको बहुत याद रखना, upper left to the lower right. नहीं समझ में आता तो वैसे लाइन ड्रॉ कीजिए, upper left to the lower right, it is a negative. Okay. In the plotted diagram in a scattergram are evenly distributed. Okay. If they are evenly distributed, that means the R is 0. That is R is 0. If all the plotted points in a scatter diagram lie on a single line, then the correlation can be, okay, be careful. It can be either perfectly positive or perfectly negative. Okay. Points lying on a straight line, it may be top right, top left to bottom right or the other way. So both are possible. So answer here is D, A or B. The correlation between the correlation between the speed of the automobile and the distance traveled by it after applying the brakes is negative because as the speed increases, as the speed decreases, because applying the speed, na, applying the brakes means the speed is decreasing, and but the distance traveled is increasing. Scatter diagram helps us to find the nature of the correlation. Okay, whether there is a correlation, and it gives you a fair idea about. Pearson's correlation coefficient is used for finding correlation for linear relationship only. Okay. Product moment correlation coefficient is considered for finding the nature of correlation and the amount of correlation both. So C will be the answer. If the value of correlation coefficient is positive, then the points in a scatter diagram tend to, okay, same thing. Positive, lower left to upper right. So lower left to upper right. So A will be the correct answer. अशोक जी, आप मांग रहे हैं कि फिर वापस कुछ और आ रहा है? अब आपके नाम से आ रहा है कि प्लीज गिव कंट्रोल। आप नहीं मांग रहे ना? नहीं, मुझे लगता है ये अभी रोकना पड़ेगा आपको। ये कंप्लेन करिए, ये तो कहीं मेरे लैपटॉप को कुछ ना हो जाए। अभी तो देखिए प्राइवेट मैसेज आ रहा है, रश्मि गिव मी द होल कंट्रोल ऑफ योर कंप्यूटर। गिव मी रश्मि, गिव मी होल कंट्रोल ऑफ योर कंप्यूटर। एक तो आप मुझे नाम से बुलाएंगे ही नहीं। नहीं नहीं, ये तो प्रॉपर जूम पे आ रहा है। जूम पे मैसेज आ रहा है, पर्सनल मैसेज, टेक्निकल सपोर्ट अशोक। मैम गिव मी द होल कंट्रोल ऑफ योर कंप्यूटर, रश्मि गिव मी द होल कंट्रोल ऑफ योर कंप्यूटर। हाँ, ये अभी रोकते हैं, ये मेरे को बहुत डर लग रहा है अभी। ये नाम वाम तक मालूम है उसको अभी। नहीं नहीं, पीछे में मेरे तो क्विक हिल है ना इसमें। ऐसा कुछ होता तो। ये देखिए अभी आपको दिख रहा है, अशोक इज रिक्वेस्ट। आपको कुछ नहीं दिखाई दे रहा? वीडियो ऑन नहीं है? अच्छा, वीडियो दिखाई दे रहा है। ये जो मैसेज आ रहा है वो दिख नहीं रहा है ना आपको? हम्म। आपके फोन पे वीडियो कॉल है ना? अभी जो फोन जिस पे आपने किया था मुझे। वो तो क्या। हाँ, हम्म। हाँ, वही मैं बोल रही हूँ ये। हमें वो बंद करना पड़ेगा। देखो, सब हम लोगों ने बंद करके देखा, अभी तो मेरा स्क्रीन भी ब्लैंक हो रहा है। मुझे कुछ नहीं दिख रहा है अभी। हाँ, देखिए वो। है ना? हम्म। नहीं, हटाने से नहीं होगा, ये एक का बंद करेंगे ना, वो दूसरे पे जा रहा है, देखिए वो रिमोट उसके पास जा रहा है। हाँ। हाँ, उसके बाद जो है ना, वो आपका है नहीं। वो मुझे लगा है ना, रश्मि गिव मी कंट्रोल, ऐसा कौन बोलता है ना? हाँ, तभी मुझे लगा, और कंप्यूटर वो सब ऐसा कुछ ना कुछ लिखा है, गलत लिखा है। नहीं, आप हटा के देखिए, लेकिन मुझे नहीं लगता अभी ये होने वाला है कुछ। अभी दिख रहा है ना, आप ही के इसमें से दिया हुआ है। हाँ, देखो वापस आ गया। टेक सपोर्ट अशोक ज्वाइंड एज गेस्ट। आप तो पहले से हो ना यहाँ। हम्म। हम्म। हो गया वैसे। 355 तो हो गया। अगली बार थोड़ा ज्यादा ले लेंगे। हाँ हाँ, आज बंद कर दीजिए इसको। जूम के साथ एस्केलेट कीजिए। Thank you all for your patient hearing. Let us go into this detail because uh, we don't want anybody else's data to be compromised. Okay. All the very best and all the best of luck for your coming exams, those of you who are appearing. Okay.